So good morning. I'm proud to be in front of you here. I think this presentation will be a little bit different from what you heard during yesterday and today. I am coming from Czech Technical University here in Prague. I am also in aviation since 14 years old, flying. And I would like to show you, as an inspiration maybe, as a bunch of ideas of how I was able, or me, or the team I'm working with, during past 10, 15 years, I was able to use Mikrotik within very, maybe sometimes it will look like in strange applications. So it will be kind of like an overview. So I will start first about myself, to introduce myself. I've sometimes in 2008, I finished the engineering degree here at Czech Technical University. Then I studied the field of digital telecommunications. So that was my kind of like my thing since the beginning. And then I spent a couple of years as a professional soldier in Czech Army. Then I realized that it's quite boring thing, and so I moved to kind of like work as a freelancer within aviation and doing research projects and started to develop some embedded applications and so on. So my technical resume is basically I'm right now assistant and researcher at the Czech Technical University, and I'm mostly dealing with CNS systems, which are communication, navigation, surveillance systems. Anything related to radios, but on the ground side, not in the cockpit. And I also teach principles of flight, the basic physics stuff, but that's just another part of the hobby. And what I'm going to talk about is our few projects. First of all, remote AFIS. That's equivalent of the air traffic control, but for smaller airports, you will see. What we do as well is a lot of radio frequency propagation modelings. For some reason, we have quite a lot of things to do related to for example, project from Taiwan, and they want to build new windmills, close to the airport. So they want us to calculate if the landing systems, the radio systems which are used for radar surveillance and precision landing, if they will be influenced. For some reason, nobody else is doing, or at least that much. But that's the question up to the customers. But what we are dealing mostly nowadays is GNSS jamming and spoofing. That's kind of like, that's the scary part of what we right now do, because we are finding jamming and spoofing in the places, even within the country. And I'm not talking about the edge with that east neighbor of Europe. Which is jamming basically everything, but it's happening, and you will see one of the projects which I will show you, which I'll try to show you, that it's really frightening thing, frightening like pace of more and more jamming and spoofing and strange people trying to hack into systems which are crucial for safety and so on. And then we're dealing a lot with ADSB and surveillance stuff and implementing sensoric networks for getting that info wherever is it possible. And mostly those projects, myself, I have been working with different platforms, let's say, over the years, and I end up with a Mikrotik always in every project for the reasons I'm quite sure and you, the professionals on that like big scale level. I'm just using it for tweaking it to very specific tasks and so on. If I have more than 10 devices in the network, then that's That's a lot for the projects I'm dealing with. But I always ended up with Mikrotik because it's kind of the cost, and the cost of implementation is absolutely marvelous, and the scalability of that thing, of that system. But for years, you know, so first projects I did, and you will see, I did 2007, then basically since then, I'm using the same platform. I try different, but always end up with Mikrotik. The teaching here in Czech Republic can't make your living. That's a hobby by itself. Well, it's probably all around the world. So even though I'm a researcher and assistant at Czech Technical University, I made my living from programming. So I'm also embedded developer and programming web applications and so on. But I'm trying to do the difficult one. So that's me in the plane. I'm also flying a lot still. I'm instructor and competing and aerobatic judge. And I named myself aviation evangelist. I've seen it somewhere like technical evangelist, software evangelist, so I named myself aviation evangelist. Nothing to do with evangelist as in the original term, but I'm proud of that. And I have done a lot of sport events where most of the motivation to stay in the aviation, or at least mine, like come from. So to the projects which I'm dealing with, or which I think are interesting to talk about in the short period of time, we are trying to bring something which is nowadays called remote tower, because there is a huge lack of personnel, qualified personnel, to control the airports. It's really, it's like terrifying. It's very difficult to teach them how to do it, how to do it in a very professional way. It's costly, and still there is lack of them. They have a higher suicide rate. That job, you know, they have a higher suicide rate. So that's also coming with a lack of personnel there. And this is happening all around Europe on the big airports. They have a lot of money. I'm quite sure you know that in aviation, if you try to come with Mikrotik into communication systems, to implement it in aviation in the big stuff, you know, the big airports and so on, you can't, because there is a huge vendor lock. Basically, company smaller than I don't know, I'm not going to into numbers, but it's basically impossible, or almost impossible. You can be like a subcontractor or something like that, but the huge vendor lock, which is kind of, I think, keeping the aviation a little bit backward in the way of implementing newer technologies. But what we are trying to do is to bring that system, that remote tower system, also to smaller airports, which obviously have even a bigger problem with the personnel, and there is like 10 times more of those smaller airfields all around the world, all around Europe. So the AFIS service, called AFIS service, is the information service which you have to, as operator of the airport, you have to give to the air traffic which is flying around, landing, taking off. You have to speak with them. But you are not the controller. You cannot control them. You're just providing an information about other traffic, weather, runway which is actually in use, or conditions and so on. So I mentioned the motivation a little bit ahead of myself, but the affordable costs means that this system usually costs over €10,000,000 to install on a big airport, and I think I can say we achieved to implement the preliminary alpha version of the system for nothing, compared to that for nothing. So This is our, like a central station, the implementation back at university, where we control the central dispatcher, the place where we can control actually multiple airports in the same time. And the airports basically we control are 3 right now. Airport Benešov, close to Prague, completely distant in Moravská Třebová, and in Chotěboř, also quite distant. So we control 3 in the same time. So it's better than remote tower. They cannot do that. They have much stricter rules for that. And it's basically built on a couple of cameras. We don't necessarily need we don't use the cheapest one, but we use something like Hikvision with a little bit hacked firmware, because we don't want China to watch our airports. But so with a little bit hacked firmware to stop some stuff and have a little bit better access to their API. With a remote controlled radio, which for aviation is not on the market, so we have to build our own radio over IP gateway and just connect it to already existing radio, but the gateways does not exist for some reason. Yes? Is the AFIS operator the one who gives permission to aircraft to land and tell them? No. It's just an information service. No controlling. You can't, there are the rules and so on. It makes sense, smaller airports. So meteo station, video processing we do from the camera some video processing with augmented or artificial reality, augmented reality, showing the operator where the airplane is and so on. But the most important part which interests you is that we are doing this with quite high integrity and availability. We can't lose the signal. We can't lose the signal, especially for the radio and also for cameras. So we're trying to make it reliable, available, secure, of course, and dynamically scalable. So we always have to implement. We were trying to use like a local resources at every airport, but it's impossible. They are in the middle of nowhere. So few mobile interfaces. If there is a wireless connectivity at the airport, then we use it. Whatever is available to bond it together to provide as much as possible throughput available for the cameras. That's the most greedy part. And we're trying to dynamically control the bonding. That's my part. That's what I'm trying to do. And the most important thing is that it's all based on Mikrotik. So the cloud switch on the server side and the RBM33 on the remote side. And I think there is still a lot of computing capacity on all of those to handle what I just mentioned. So 3 airports, and so far we're doing fine. Of course, on the server side, there is a server which is doing the video feed calculations and the artificial reality and the surveillance and so on. But all that goes through, including the bonding and including the high integrity. If you please understand that in aviation, the integrity is something where you say, okay, this system have 99.2% integrity, which means that 0.8 errors in communication will not be undetected. That's kind of like a definition. So if I talk about high integrity, then it means that it's, let's say, almost all the time usable, and if not, then we are able to say that it's unavailable, and the airplane which is relying on that service can choose another scenario to stay safe. That's the basic idea. So yeah, so that's remote AFIS. Then forgot there is a little chart how this is interconnected, but I understand that it's more for illustration because I don't feel I have a that much time to talk about that in detail. But basically we have meteo station, set of cameras, router and backup router, and on the other side, on the server side, both. The radio is connected, radio and some of the surveillance data are connected through the voice IP server, basically through the voice IP technology, and because there has to be also telephone connection between, that's what law says, or the rules, the aviation rule says, there must be connection between those both sides, between the airport and the operator. And so very simplified diagram. And this is how it looks like in real in Benešov. This is a month-old picture. And this is, this picture is actually, the left one is actually taken later, but it was snowing again. It was such a beautiful day when we installed it first time. So the installation happened late last year and early this year. So that's it. And little funny topic, because I spent past 3 years by developing this system. So innovation never stops, and when we are finished, it will look something like this. So requesting clearance to land, and the answer, automated answer from the system will be, if you are calling about landing clearance, please press 1, and so on. It's a little bit of over-engineering never hurts, right? So, okay, so that's one of the projects. The second one I want to mention is detection of interference or spoofing jamming, as I mentioned. What the projects we are dealing with, and of course not only me, the lab I'm part of. We are right now. We have been asked by the one of the airline operator here in Czech Republic, based here in Czech Republic. Please, we have problems when we are taking people to Egypt for vacation. Over Turkey, basically there is no GPS. It's jammed completely. So they are using the other systems which are there. That's fine. It's still safe. No worries. But can you help us maybe to understand what is jamming it, how it works, so we can deal with it and prepare our crews for early detection and so on. That's one thing. But the project which I would like to talk about is more ground-based, and we deployed. A year ago, we deployed a couple of boxes. It started as a very, let's say, very like a hobby project. It looked like a hobby project from the beginning, but it came from the situation where we measured interference, accidentally measured a lot of interference close to major highway, and also close to the highway which goes around the airport. So, what interference of GPS? I forgot to say of GPS. Where it comes from? And it comes from the trucks, which are trying to block the sky toll, the highway toll system. Which, okay, that's none of my business. Everyone is trying to make living somehow. But if they are driving close to the airports, and since the airports are usually close to the highways and the cities, because that's kind of like where the customers who wants to fly are, then we have a serious problem, because usually the planes are low and trying to land precisely. And current situation in aviation is to move from a technology which is 100 years old. It's called ILS, Instrument Landing System, operating close to the lower frequencies of FM radio, and higher frequencies of FM radio, so 118 and around 118 megahertz and around, and it has some disadvantages. So the idea is to move to GPS landings or GPS augmented landings, and this is kind of blocking it like this is like a showstopper for that. So we are doing it on the national level, in the Czech Republic, that we have a set of boxes like this, 3D printed right now by myself. Solar powered, those were the early stage without the solar panels attached, but it looks like this. It's around the airport. Right now, 12 of those boxes are like set of 12 on 3 places right now. And we are sensing the RSSI level, GNSS, GPS L1, and I can tell you there are interferences. We had last year truck stopped for like 5 days in the logistical park near the airport with, I don't know how much, what was the power output of the jammer he had in the cabin, but must have been like 6-7 watts because it was jamming half of the airport. So that's one thing. And we have been, last year we have been already asked, and that's in development, the radio altimeter interference from 5G networks. Probably you have seen the information from US about kind of like, the regulator made it completely wrong, and they sold the frequencies to the operators, and we don't know what to do because it's unsafe anymore to land on the airport where the base station is closer than 5 kilometers to, because it's jamming the radio altimeter. Okay, but Europe is fine. Nothing is happening in the Europe. Don't worry, we have completely different frequency plans and so on. Except it's not really true. And we are slowly realizing, or they are slowly realizing, that it's kind of like, it's a problem. I don't want to, I cannot go into exact details, but so we are also we are going to put this spring sensors for assessing the interference from the 5G networks. And because the problem is that the crews of landing airplanes came with, okay, we have a problem because it's off a couple of meters every time we land. So, and since they always come up with something, we started to develop a version which contains software radio, and we want to check the whole spectrum and get some other possible interferences and so on. The most important thing with this project, we do not just detect level, but with that number of sensors, we also doing the multilateration. So we finding the position of the source, so we can send someone there and deal with it, or they will deal with it. And it's online, it's running online. So there is one of my colleagues installing the first version. The boxes between each other communicates on 868 or using Wi-Fi. They are very simple devices built on Arduino MKR because of the initial cost, and because I also like them because they are cheap and quite powerful, and due to the power requirements. The main box contains Raspberry and Mikrotik RBM11G, which does all the communication, the live communication, and we have a live alerting if there is a jamming, then live alerting, and somewhere where is the approximate position of the thing. So the server side is built on 411, which I got somewhere. I don't know where, but I got it, maybe from Jaromír. By constantly supporting us for testing different Mikrotik devices and so on, or his company. And we managed to do it completely solar powered. There is a lot of batteries, and the solar panels are for the big box, for the main box, are quite big to keep it running overnight constantly, but it works very nice. And we are deploying it, constantly changing, and every month coming to the airport, which is nice because you can stay in that landing row and watch the airplanes from a couple of meters only. That's awesome. This is the deployment around the runways, around the landing line, the landing center of the runway. So we have it like this, like this, because it's close to the highway. So it's always like considering the highway and the runway. And this is the example of jamming. Okay, minus 50 dBm. Quite a jammer, actually, in this case. And this is like the different colors are different sensors. So using this, we can get the information where the jammer is, and it works. It works. Looks like we will have some fun in the future with that, especially the airport operator. Yeah. So that's it. And then I have another project which we do, ADSB analysis. ADSB is the digital information which aircraft broadcasts about their position, their identification, and some other details. And we have them in different places, and with central storage, and we doing using Cassandra database, doing some big data magic with that, trying to analyze it and find specifics. And especially the ADSB nicely also shows if there is a GNSS jamming or GPS jamming, then it's also seen in the ADSB. There are specific ways to find out from ADSB. So, and we live stream it out. It's basically like flight radar, if you have seen flight radar or stuff like that. However, we have the raw data, so we can work with the raw data and doing some multilateral calculations, again trying to find a position of the airplane and then compare it with what they are sending, and so on. But it's again, of course, there are sensors which we have a radio interface and so on, but the rest is built on Mikrotik. Very ancient, not very ancient, but a little bit ancient 951 with the sensors where they are located, and the cloud router on the server side connecting the traffic. The thing is that the sensors are not recording; they are streaming, live streaming data. It's 400. The already processed data in the database gets 400 megabytes per 20 minutes because it's stored in 20 minutes chunk. So it's a lot of data they are streaming raw. So it works for years already. For 5-6 years it already works with that infrastructure. Or this is newer, but on that side it works for a couple of years already. And this is yesterday morning, what we are sensing and what we are dealing with and what we are trying to process. So we hear nothing happening here. It was quite early morning, so just no small planes, just the big ones, just the big sausages. Keep taking people to nice vacations. So those are kind of like the sole university projects which we are working on, researching, and so on. But also, thanks to the help of with the help of Mikrotik, I have done personally, due to being in aviation and so on, a couple of projects or few projects, and I have two of them here to show you. So I think interesting application of the Mikrotik again. So I've done ACRO Online, which is a system or web application for management of the aerobatic competitions. And as you can see, there is advanced category, and there is very familiar name. See, recognize. He's good. He's flying nice. And we have done. We had done in the past, in a couple of years ago. We have done also with the output to television and so on and so on. And it requires a lot of calculations and lot of streaming. And judges have tablets. They're putting the marks for the flight into the tablet. And guess what? It's connected all with the Mikrotik. because it works. So battery powered, provides Wi-Fi for tablets and usually mobile connection to the server which calculates the results. And then the other projects, which was probably the most insane one I came up with, was, okay, let's put some cameras to aircrafts and let's stream it down live. And we did. It went to television. We started developing it 2007. This happened, those pictures are from 2011. And it was all Mikrotik based since the beginning. We had cameras, and they were connected through the single Mikrotik on board with two interfaces, with two Wi-Fi interfaces. And not exactly standard Wi-Fi protocol, I have to say, but bonded through balanced bonding, and one antenna on the top, one antenna on the bottom of the plane of each one, and with a little bit self-made planar antennas, I'll show you in the picture, and very funny looking ground station with later automatic rotator, but you'll see that the automation was achieved by very nice plastic handle in the beginning, and with antennas a little bit a 90-degree offset polarization, and yeah, we did it. It went straight to television. But then came Red Bull and completely ruined our ideas and did it for a lot of money, and it was based on Mikrotik. 433 GL, if you remember that thing on the ground, and RB411 in the aircraft. And there are some pictures. So this is the funny-looking antenna rotator. This is in China, actually. Very interesting place here. But so this is antenna rotator. This is that planar antenna I was mentioning, and this is a very professional, self-made interconnection network. By the way, there's a funny story. I needed to put some kind of, because this has to be located like close to that area where they were flying, and you know, in China it was difficult to explain them what we are trying to do, especially whenever I mentioned that those are antennas and we are broadcasting something. They said, no. Well, and then a military guy came and confiscated, and then hour later they gave it back. So this was happening like twice a day. However, so I needed to put somewhere some kind of, I needed the signal to go from here. This is from the aircraft, obviously, and I needed to send it somewhere. So I end up with this. I said, can I put it on the top of the tower? That would be very, very good. No, it's a control tower. It needs to be like, yeah, but there is no one, and you have a second one there. By the way, why you have a second one? Yeah, they built the one, and they made it fancy, so they cover it by the glass completely. But they forgot to do any windows, you know, so it was unbreathable, because it was like 30 degrees outside, so that was like, yeah, you can grow probably tropical fruits inside, but so it was available. Then in the end, I realized that it was available, so I can put anything I can. And the worst part really was to bring it to China. This was to bring it to China. They always told us, you can take anything, don't leave anything. Whatever you came with, you have to take, but you can take whatever you want, but don't leave here anything. So this is the installation in the airplane. That's the antenna, camera, and professionally mounted Mikrotik with the silver tape. Come on, it fixed the space shuttle, so why not to hold a little metal case in the back of the aerobatic plane going with AG's forces. So, yeah, that's the last one. I have a few minutes spare, thank you. I would like to once more. I would like to use the opportunity to thank the organizers for an opportunity to talk about those projects. And again, I've spent with Mikrotik a couple of years, I bow in front of you because you are the professionals. You're doing as in the previous presentation, all the advanced stuff. And I'm just playing with one or two devices and so on, but I try to put them on very weird places. And I want to thank the organizer to have opportunity to do it. And especially I want to thank Jaro, seriously. Because since the beginning, he was supplying us, or the Sysdatacom company, they were helping us because all of those projects are non-profit thingy. You know? Please understand they are non-profit. They are either at the university or my own ideas in the aviation. And he supported us with most of the devices and so on. So thanks again. And this would never be possible without him. Thank you.
Thank you, Vladimir. There is any question?
Oh yes, of course,
about
absolutely.
The presentation
shoot.
that he did? Amazing. Oh yes, we have one.
Hello, great presentation. So, in case of the jammers that were mentioned, you said that, or the map showed that usually the jammers were in the roadside. Have you tried actually taking a jammer yourself and moving around in the airfield?
Very many times. But it's not, you can't do it at Prague airport. It's kind of like, they will not find out without us, actually, if we do that.
Yeah, that is the reason, you know.
Exactly, but no, like from the professional point of view, it's not a good idea because the planes are really using the GPS systems for. We do it a lot, a little bit more far away from the airport. We even did it at the airport, close to the airport. Nobody realized. We waited for the time when that runway was not in use. But yeah, we're testing. We have pretty strong, and we even have pretty strong interference things, you know, like disruptors and spoofing things. With agreement of the Czech Telecommunication Bureau, actually. We have to for testing and for those purposes. So
I see. And was the success percentage of the, or the percentage of the accurate data that you get from those geolocating the jammers?
That's how we convinced the Prague Airport and Air Traffic Services of Czech Republic to include us, to put the stuff at the airport, actually, from the beginning. That we had some good results from measuring first at the highway, at the D1 highway, that we found out that there is 2 trucks per hour coming through one single gate at 34 kilometer. And we said, oh, that's a problem. And we did some, like a manual testing with our own jammers. And we realized that it's very close, and theoretically calculated area which is jammed goes up to something like 200 meters, which is exactly the airplanes above the runway, above the highway on the runway 24, which is like we are here, from this direction landing, they are in 50, 60 meters above the highway. So it is influencing. So, but we were able to convince the management of Airport Prague to start to dig into this problem by showing them the results which we also artificially created and which we measured.
Thank you.
Welcome. There was one.
Thank you very much for the presentation. But if we can jam something, is there not a way to jam the jammers? I mean, can you not neutralize?
Yeah, you can jam the jammer, but your device still doesn't work then. If you jam the jammer, that's the problem. And also the problem is that I believe you are all familiar with the Wi-Fi and spread spectrum and frequency jumping. That's exactly what the GPS use. So to find out that you are jammed or to find out that you are spoofed. That's even more problematic, to find out that you are spoofed, because the current spoofers are becoming very advanced, and they will spoof you just a couple of meters. And but with landing plane, that's a problem, a couple of meters, right? So the jamming is the problem is that to find out that you are jammed, because you don't have much time to find out that you are jammed, and the system, the GPS system is not like really jammed, you know. You lose satellites, but you lose some of them, and the problem is that the accuracy decrease under some level. So it's not like jamming of the FM radio station or something. The GNSS, is, thanks to the complexity, is a little bit more difficult, or a little bit more finding out is a little bit more difficult and dangerous actually, because you don't have much time. Yeah, that's as I said, we will be at the subjects I am teaching. We have 3 semesters to talk about that. That's awesome, you know.
But I think you should continue talking about it, because I mean it's quite scary to realize.
Okay, yeah.
Thank you.
I was trying to scare you and then show you some nice pictures. Okay, thank you very much. And enjoy lunch, please.